Whenever I visit data centers, I'm sort of on this point, I'm always curious to know. I would ask the guy who's touring us around a couple of particular questions. One is how it is that they separate the servers that are supposed to handle data from different jurisdictions. You may go into a data center and you've got servers that are processing the data from Canada, from Japan, from Brazil, that are contracted out. And the laws that organize this are segmented. Weird borders inside the center itself. Sometimes it also means putting the servers, you then ask, then which are the servers that are using the most energy intensive? Inevitably, it's the Bitcoin mining servers. The ones that are mining the cryptocurrencies, Bitcoin, Ethereum, Litecoin, Solarcoin, what have you. And at first blush, this may seem like the height of stupidity to waste kilowatts of energy on the manufacture of digital Lucky Charms. However, a currency whose reference is ultimately scarce energy itself, as opposed to gold rocks, for example, is a notion that's perhaps anything but stupid. Though it's true, the histories of some of these are a bit spotted. Now, PHI, our next project, is a platform that hinges exactly on this link between energy and currency. For the PHI platform, the blocks are produced along with new nodes in a renewable energy network. And so the currency incentivizes not more mining rigs buried in data centers, but more solar rigs above ground, absorbing and sorting usable electrons. As you'll see, it's an application suite that allows users to model renewable energy networks, that is to map their current state, to predict how flows of energy may shift, a kind of weather report for energy flows, and to simulate possible flow patterns based on adding new nodes to the network. The present, the likely future, and the possible future, they can be figured in a single dashboard. Now, energy load management application suites may not seem like a likely frontier for design innovation, but with PHI, I think they prove to be. As you'll also see, as in the age of Slack and WeChat and WhatsApp and the Siri and Cortana, the merging of message app journaling interfaces with ever more complex bots with AI capabilities is the future of interface design to management of complex systems. I read PHI not as a pat solution to a complex problem, but as an open equation that would organize users' relations to the systems with which they are already bound. Energy, value, simulation, in the image of their aspirations and intentions. Infrastructure may not be a dumb battery of human work, but it is a medium and resource of social energy. It's my pleasure to introduce to you PHI.
Thank you, thank you.
Cheers.
Hello, we are PHI, and today we would like to present you our project that we have been developing here in Strelka for the past 5 months. During this short but intense period of time, we were working on a proposal for an alternative energy distribution and consumption, trying to find a way how people can benefit and gain equity in renewable energy production. But first of all, we would like to introduce ourselves. My name is Sasha Smirnova. I'm an urbanist from Minsk, Belarus.
I'm Callum Bowden, a designer and researcher currently based in London.
My name is Ivan Yin. I'm a designer from China.
Hello, my name is Artem Stepanov, and I'm an architect from St. Petersburg, Russia.
My name is Corey Levinson. I'm a software developer and a data analyst from around New York.
So let's start from the most important question, why we are doing this project. PHI emerges out of the Russian context and its unique history of centralized electricity. In 1920, Lenin said, "Коммунизм – это советская власть и электрификация всей страны. Communism is a Soviet power and electrification of the whole country." Now we can experience this extreme centralization on our own lives. Starting from small issues, like for example, hot water cuts off that we are all so familiar with, to global problems as remote hacker attacks on energy infrastructure that can leave entire cities without electricity. But the main reason why we decided to do this project is current situation of main grid in Russia. Its concentration around no longer existing economies, like for example factories, leaves 67% of the country without reliable infrastructure. Some remote regions that don't have connection to the main grid and rely on expensive diesel fuel delivery have real economic incentives in order to shift towards renewable energy sources.
Recent developments in energy, user interface design, artificial intelligence, and blockchain networks create new ways of interacting with infrastructure. So, renewable energy is now a viable alternative to fossil fuels for powering our cities. Since I've been in Russia, I've heard quite a lot of people be quite skeptical of the possibility of renewable energy to provide a reliable source of energy, but I have experienced more hurricanes, more rain, more extreme wind than I did over 6 years in London. So I think it's definitely something that can happen here. Data visualization allows us to make sense of complex systems. Artificial intelligence enhances user interfaces to make them better anticipate our needs and to provide more intuitive interactions. Chatbots enhanced by artificial intelligence can help us with everything from online shopping to finding trendy shoes to paying boring taxes. And blockchains, which are distributed databases that store all data on each participating computer, create value from peer-to-peer networks, which are at a one-to-one or person-to-person scale, as the security of the network doesn't rely on a central authority.
And so, with all of these recent developments in mind, we look towards the future of what's possible for global energy networks. We present our project, PHI. PHI is a software platform for reimagining our relationship to energy infrastructure. And it has two main components. The first is an intuitive chatbot interface that allows users to simulate and create clean energy networks. And the second is a blockchain-based token system that allows people to relate to each other and to energy infrastructure in new kinds of ways. So we're going to walk through first our token system with you. So PHI has 4 tokens. Tokens allow us to reimagine our relationship to renewable energy. Electricity in our system isn't traded in the traditional sense, or sold in the traditional sense, I should say, but it's traded for tokens that represent things like the amount of energy stored in batteries, possibly reputation scores, or the amount of energy that's not consumed. So our first token is called joules. With blockchain systems, you can actually digitize assets and create digitize physical assets like energy that's generated and register it on a communal ledger. So with Joules, we do exactly that. It is exactly the digitization of the amount of energy that's generated and traded throughout a network, represented as a token. And seed rating is a reputation score that grows with a peer's increased energy trading throughout the network. So we wanted to create an incentive for people to be trading within a system, and whether you're a house or a school or a supermarket, your seed rating or your reputation score will increase as you trade more energy within the network. The third token is called negawatts. Negawatts is actually a token that is inversely proportional to your consumption. So as you don't consume energy on a certain day, you receive negawatts in return. And within our system, negawatts can actually be traded for joules. So what you don't consume on one day, you can then trade later in the future for peers on another. And finally, we have PHI. PHI is more your standard cryptocurrency token. It represents the overall value of the PHI platform and the PHI network, and it has two main purposes. The first would be financing the development of the PHI platform, and the second is financing the actual real energy infrastructure projects that our simulation environment facilitates.
Okay. These 4 tokens described by Corey are reflected in our intuitive interface. We are very happy to introduce today a new way of interaction with engineered systems. Our interface has 2 main elements. The first one is a grid-based map with peers, generators, and power cables overlaying the geographical layout. And on the left, we have a chatbot with informative status bar on top. Oh boy, only a map and a chatbot. And this all is done instead of existing ugly and complicated power grid management software. So, map and the chatbot. Our interface communicates the 4 phases of our projects. These 4 phases allow users to simulate peer-to-peer energy transactions and create value for the future projects, to invest in network development, to create energy infrastructures, and to reorganize communities to incentivize network growth and activity. So let's start with the first phase, simulation. And now me and Corey will run a short demo of our simulation, and I will play the voice of Phi.
Check, test. Okay, so this is our simulation environment. This is live today, online, so you can view it yourself. And when you first load, as Artem just described, you see the chatbot here on the left, and then the grid layout is on the right, and Phi greets you when you first enter.
Hello, I'm Phi, your interface to peer-to-peer energy. I can help you design, simulate, and manage renewable energy resources and biosensors.
Sorry, I'll just make that a little bigger. So maybe when we first start, I want to ask Phi some questions. A good question to ask is maybe, is this a simulation or do projects actually get launched in the real world? So let's ask Phi, is this a simulation or do projects happen in the real world?
The Phi simulation is the initial phase of Phi platform, which allows users to design a test clean energy plan for a given location.
Okay, well maybe I want to get a better understanding of how the real world parts happen. So let's ask, how do projects get launched for real?
At the moment, I can only simulate networks based on real data. But in the future, it will be possible to involve multiple users for decision-making on investment, voting, and management of real-world energy networks.
Cool. So let's go ahead and get started.
Please choose one of the locations below to launch your simulation.
So for now, we have 3 separate locations that we have running for our simulation: Ust-Karsk, Valam, and Murmansk. We can select Ust-Karsk today.
Добро пожаловать в Усть-Карск. Welcome to Uсть-Karsk, a remote off-grid community located in southeast Russian region with great potential for solar power. You've received a 10,000 PHI coin investment to further develop the renewable energy network in Uсть-Karsk. On the map to the right, you'll see the local PHI network in Uсть-Karsk. PHI networks are made up of 4 types of components: piers, solar panels, wind turbines, and cables. To begin building your network, select from the buttons below. Don't forget, you can always ask me anything if you have specific questions.
So as Phi just described, we can now see the network layout here on the right. And these dark circles are the piers, and I should note that the larger circles that you see outlining them are actually indicating the consumption profile of that pier. So maybe a certain house consumes less than a supermarket, and that'll be reflected in the size of these outlining circles. So before we start building out this network and adding more infrastructure, maybe we want to again ask Phi some questions. I'd like to get a sense of whether wind or solar is better in this region. So we can ask, does wind or solar have more potential in Uсть-Karsk? And Phi responds with a nice informative graph. You can see that clearly there's quite consistent potential for wind power over the year, but for solar it's much higher in the summer. But maybe to be a bit more specific, I'd like to know, if I had to pick one, because I'm still not quite sure, which should I go with? So we can ask Phi, if I had to choose or to pick one type of generator, which should it be?
It might seem hard to believe with all the rain lately, but I would recommend solar.
Okay, so we can go ahead now, and if we click the Buy Generators button, you'll see all of these gray squares and gray triangles illuminate. These are actually the locations for predetermined generators, and if we click on them, we can add them to the network. You can see the numbers get deducted from our budget. And then if we click the Install Cables button, Phi tells us that now actually we can connect these pieces of infrastructure to the network. And once we've connected a few cables together, now I'd like to kind of simulate this and see sort of how energy propagates throughout the system on this day. So we can click the Next Day button. And then what we'll see is you'll see energy visually kind of propagate throughout the network, and you'll see it get disseminated to the piers. And then Phi will also kind of be informing us along the way of what's happening. So here's the energy getting generated. And now you see that all of these piers, the outlines have filled in. And the ones that have filled in all the way and are now colored, this is showing that a pier was fully satisfied by Phi, by the Phi network. And the ones that are only partially satisfied, let's say only got 30% of the energy that they desired that day. Now all of this is stored in aggregate on the status bar in our health meter. So we can see that 59% of the energy that was desired on this day was actually consumed by all of these piers from the Phi network. So we did pretty good. And then this coverage meter is telling us that the simulation that we're running is covering about 8% of the total population of Uсть-Karsk. So as you proceed with the simulation, you can build out pieces of infrastructure and try and increase both your health and your coverage to account for as much of the local population as you can. And now Iwen's going to talk about the phase after simulation, where we actually start to see how these projects can take ground in the real world.
Yes. As Corey mentioned, we are looking forward to expanding our simulation into a multiplayer mode, which will allow the second phase of Phi, Invest, to come into play. As you can see, you'll be able to chat and work with your neighbors, suppliers, mechanics, and so on to simulate your ideal city. This simulation that you design can be submitted to the network so people can vote on it. In this way, everyone plays their part in how to spend the communal fund through collective investment. Instead of having one mastermind deciding what's the best for the city, we would like the decision to be made from the bottom up. Now, after your community decides on an investment proposal, the create phase starts. You can start setting up your infrastructure and putting the simulation into the real world. Once you plug it into the fee platform, trading will automatically begin. And the data your infrastructure produces can be shared to the network. So you see, after you're sharing your data to the network, you'll be rewarded with fee coin because you're helping other people to make better simulations. So you see there's a constant loop exists between simulate, invest, and create, which will help the fee network to grow more precise, efficient, and robust.
The final phase is reorganize, and we're now going to talk about the implications of fee. Computational networks index the consumption of electrical energy from global data centers that together consume more power than many large countries to the energy-intensive proof-of-work consensus mechanism at the base of blockchain networks like Bitcoin or Ethereum. Fee is about rethinking the relationship between computation and energy. Anthropological understandings of value foreground the social processes at the base of economic exchange. Value is something that's active and created through trust. Blockchains allow us to, blockchains and the tokenization of things like the amount of energy not used or reputation allow us to incentivize alternative forms of value that are based on reciprocity or the sharing of resources.
Recent development of renewable energy and networking systems mean the new ways of interacting with infrastructure are now possible. The cost of renewables is lowest it's ever been, and blockchains and public ledgers that store all data on each participating computer allow the power to disseminate through networks. The transition from fossil fuels requires new ways of coordinating humans and non-humans. By designing and simulating peer-to-peer networks, we are imagining new collaborative energy future that can provide the opportunity to incentivize and codify social obligation, trust, and reputation. Fee starts as the foundation, with the driving force of life, energy. So this is our project Fee. If you want to know more about it, you can go to our website, fee.is, where you can launch the simulation and create new energy future or design new energy future. You can also find there a link to our pink paper document where you can read about our project in more detail. And of course, if you have any questions, we will be happy to answer them after the presentation. Thank you very much.